Hello friends, welcome to my channel. Let's have a look at problem 973. Key closest points to origin. So this video is sort of a continuation of the video for problem 692. So in this video, we are going to share some treatments based on either modifying the sorting key or overwriting the dunder less than method. First, let's look at the statement, and then we share the code and explain the code. First statement. Given an array of points where each point is a two-dimensional vector in the plane, so we are required to return k closest points to the origin 0, 0. So the distance is Euclidean distance. So we may return the answer in any order. The answer is guaranteed to be unique except for the order that is in. So let's look at one example to digest the requirement. For example, in example 1, so there are 2 points, and k equals 1. We want to find the nearest nearer point to the origin. For sure, this is -2 and 2, right? Because the radius of this one, or the distance of this one, is 8. Take square root, right? So we get this one. So similarly, you can interpret example 2. So before we do the analysis, let's look at the constraints. First, k is greater than or equal to 1 and less than or equal to the number of points, and the latter is bounded above by 10 to the power 4, right? So the second constraint is about the range of the vector components. So with that said, let's look at the coding. So we're going to share some parallel treatment for this problem with respect to Leetcode problem 692, or similarly, so you can do problem 347. So first, I'm going to write a verbose way. So verbose way, in some sense, brute force. So here, first, I'm going to sort the points, and then we pick the first key. So here we can do the points sorting in place. So here the case is to specify the key. So here we have a point. So we want to make sure that we sort the point from the nearest to first with respect to the origin. For this way, we can check distance, but also we can check the square distance, right? So we are going to use square distance. In other words, we don't need to take square root because square root is a monotone increasing function. So this is the sorting, and next we just need to return points, the first key elements or points. So that's it for this problem. So now let's do a check. Yeah, it passes all the test cases. So next, I'm going to copy this class signature, class name, and method signature, and then so I'm going to call this one v. So in the second version, I'm going to overwriting the dunder less than method. For this, I'm going to write a wrapper class. So this is also very straightforward. Let's see class. I'm going to call it point. So the initialization is actually trivial, sort of. So we get a point. So let's see. I use capital letter P to notice that it's a vector. So self vector equals P, right? P is a list in this problem. So, but you know, it can be tuple in general. So then let's write this self other. So let's call it let's say other. So both self and other can be interpreted as instantiations of the class object. And then we want to define an order relation. So the reason we are going to our overall idea is to use a heap. So we want to retain the nearest distance point. So we want to pop the further ones. So I'm going to define like this. So the order relation, self v0 square plus self v1 square. So the larger I will regard it as the smaller. So so we're going to other v0 square plus other v1 square, right? So this defines the order relation, right? So this order is tailored to the problem logic because we want to retain the nearest data points to the origin, the key. So now we are ready to do the problem logic. So here I'm going to first initialize a heap, and then also we want to initialize a counting variable, count the number of elements in the heap. So now we are going to do iterate for p in points. So what we're going to do is to heap push. So we're going to push an object into this heap. The object we're going to push is the point p, right? So this way, each time we push an object, we're going to increment the length by 1. So now let's do a check if this is larger than key. So we're going to do heap q, heap pop. So notice that the pop will pop the mean element in the sense of the heap order, but the mean element will be the elements which is further to the origin. That's exactly what we want, right? So now after this, so we're ready to do the return. So the return, we need to return the list, right? The corresponding point. So object, so vector for object in h. So that's the second solution format. So here basically we just need to use the heap, but using a wrapper class. So with that said, we're ready to do the check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the cases. So I guess that's about it for this problem. And in this video, we shared two lines of idea. One is just do sorting based on tailored sorting keys. And the second line of idea is to modify the dunder less than method. So with that said, that's it. Thank you.